Hello, Algebra 1. Welcome to part 2 of our functions mini topic. We're going to talk about operations with functions. And yes, as you think of operations in mathematics, we're talking about addition, subtraction, multiplication, division. Now, we're going to stay away from division because that's a little more difficult. If you take Algebra 2, you'll get there. But let's talk about addition, subtraction, and multiplication. So you might see notation that looks like this, right? So you might see in a parenthesis, f plus g of x. Well, that simply means you're going to take the function f of x and you're going to add it to the function g of x. And that's it, right? Now, you're going to see linear and quadratic functions. All you have to do is combine the like terms. That's it. And that's all we're going to do there. Okay? We're also going to do subtractions. You might see f minus g of x, which again is f of x minus. And now I'm going to put a big bracket around g of x. The reason I'm doing that is because you need to remember that when you subtract, you need to distribute the negative into that second function. But then after you do that, you're going to combine like terms. So you distribute the negative and then you combine like terms. And then last but not least, you're going to see some multiplications. You might see f times g of x. And that's just going to be f of x times g of x. And when you handle this, all you're going to do is distribute. Right? Potentially use the box method, or you might just do the rainbow. So you might have like a binomial times a trinomial, a binomial times a binomial. So this is definitely from topic 7 with the distribution. All right, so let's get right down to some of these operations with functions. Again, good review of combining like terms, all kinds of fun stuff. So it says, let f of x equals 4x plus 3 and g of x equals x squared minus 8x plus 15. Perform the operation and then find the domain. So we're going to multiply f of x times g of x. So we're going to take 4x plus 3 and multiply it by x squared minus 8x plus 15. So for those of you who want to do the rainbow method, yes, you would take 4x and multiply by x squared, negative 8x and 15, and take your 3 and multiply by x squared, negative 8x and 15. But I'm going to come over here and I'm going to show the table method, right, or the box method. So I'm going to put my 4x and my positive 3 here. Sorry about that. I'm going to put my x squared here, my negative 8x here, and my positive 15 there. And again, when I fill this out, I'm looking for the 6 terms I get in here. Because remember, a binomial 2 terms times a trinomial 3 terms is 6. And again, let me make this 3 more prominent. Okay, so let's go ahead and start multiplying. So 4x times x squared, that's 4x. And again, this is an x of the first. X of the first and x of the second make x of the third. 4x times negative 8, that's negative 32. X times x is x squared. Again, this x has an x to the first. And 4x times 15 is positive. 4 times 15 is 60, and the x just comes. So there's the distribution of the 4x. And now I'll do the 3. Positive 3 times x squared is positive 3x squared. Positive 3 times negative 8 is negative 24x. And positive 3 times positive 15 is positive 45. And now comes combining like terms. So the first term is going to be the highest power, 4x cubed. Then you're going to combine the x squared terms. So positive 3 and negative 32 is negative 29x squared. Then you're going to combine the x terms. This is negative 24 and positive 60, which is positive 36. And then the positive 45 comes at the end. And that is going to be the product of your 2 functions. So it's a simple multiplication of polynomials question. Now, we're going to talk about domain, right? So the domain of a linear. So this is linear. So for a line, your domain is all real numbers. This is a quadratic. Again, because you have arrows on the left and right, your domain is all real numbers. So when you multiply them together, you get a, this is called a cubic. It's a third degree polynomial. A cubic looks like this. But again, you have arrows on the left and right, so it's going to also have a domain of all real numbers. And again, that's from negative infinity to infinity if you have to use interval notation. So again, we're not going to get into the hectic domains. So all of your domains should be all real numbers because we're sticking to linear and quadratic, and maybe on the next one you'll see a cubic. But again, it's just a polynomial. Okay, next, here we go. It says, for the following functions, find f plus g of x, and then find f plus g of 2. All right, so here's what we're going to do in part A. We're going to take these two functions, and I know they have fractions. It's okay, right? We're going to deal with it, and we're going to add them, right? So for part A, I'm going to take x cubed minus 1/2 x squared plus x. And I'm going to add it to, now notice since I'm adding, I don't need to put the second polynomial in parentheses, plus x squared minus x over 4 minus 5, right? And now I want to combine any like terms. So I only see one x cubed, so that's going to come here. Now I do see some x squareds. I see a negative 1/2 and a positive 1. Positive 1 can be 1 over 1. To make that have a common denominator, multiply the top and bottom of this 1 over 1 by 2 to make it become 2 over 2. And now I can combine negative 1/2 and positive 2/2. Negative 1 plus 2 is positive 1. So this is going to be a positive 1/2 x squared. Right? 1 minus 1/2 is 1/2. Right? So there we go. Now I'm going to add this 1x to this negative. This is actually negative 1/4 x. Right? So again, 1 over 1. Make this 4 over 4, and 4 minus 1 is positive 3. Keep the denominator the same, 4x, so 3/4 x. And then this negative 5 is the only constant term, so it comes down. Now again, you could have taken negative 1/2 and added 1 in Desmos and got the 1/2. You could also have decimals, I don't care, but this is probably the most correct way to write that sum. Again, we didn't be asked for it, but the domain would be all real numbers. And now we want to evaluate that function when x is 2. So now we're going to take our x value and replace it with 2 each time. So we have 2 cubed plus 1/2 times 2 squared plus 3/4 times 2 minus 5. And again, just type this in Desmos all at once, and I'm going to do it for you. Okay? Just want to clear this. I'm going to get out of here, go to Desmos. Again, don't overcomplicate things. So we have a 2 raised to the 3rd plus a 1/2 times 2 squared plus a 3/4 times 2 minus a 5. And there we go. I got 6.5. So if they accept decimals, 6.5 is what it comes out to be. If they don't accept decimals, press the fraction button. 3/2 is also 6.5. And there you go. Okay, and then last but not least, number 3, example 3 on our notes here. So it says, words. Okay. So it says a florist charges $8 for delivery plus an additional $1 per mile from the flower shop. So that's what the florist charges for your flowers, right? So that's what they make. That's their income. We call that their revenue. The florist pays the delivery driver 50 cents per mile and $5 for gas per delivery. If X is the number of miles the delivery location is from the flower shop, what expression models the amount of money the florist earns for each delivery? So this is an economics or a business application. So profit equals revenue minus cost. So typically in terms of functions, to find P of X, we take our revenue R of X and we subtract our cost C of X. And this is your general, business math equation here. So this first sentence is our revenue. This second sentence is our cost. And we're talking about from the florist perspective. Okay, so what does our florist revenue look like? So for the revenue, the florist makes $8 or charges $8 for delivery. So that's a flat fee of $8 and then $1 per mile. Well, if X is the number of miles, you multiply the $1 times X. You could put 1.00X, but I'm just going to put 1X. The cost for the flower shop is for the delivery guy, right, or girl. So we do 0.50, so 50 cents per mile, and then $5 for gas, and that's a flat $5 fee. So there's your two functions, right? So now we need to subtract them. So to find my profit, I'm going to take my revenue, 8 plus 1x, and subtract. And now look what I'm going to do. I'm going to put the cost function in parentheses. If I don't, I will forget that I must distribute the negative. So now this is 8 plus 1x minus 0.5x minus 5. And let's put it in, I don't care what we do. Let's do the x's first. So 1 minus 0.5 is 0.5x. And then 8 minus 5 is 3. And there is this florist's profit equation. This is what they should expect to earn for every delivery. 50 cents for every mile plus $3. Nice. All right, so here is part 2. Good luck on the practice.